In this video, we will learn about demand elasticity. We will start the video with a scenario. Let's assume that you maintain the social media accounts for local businesses and you charge each business $2,000. You currently maintain social media accounts for 12 businesses per year. Now that you realize your costs are rising, including the opportunity cost of your time, you're thinking about increasing the price to $2,500 per business. Now you know that according to the law of demand, if you raise your price, you will not have as many accounts to maintain. In other words, your customers may leave you. So now that you know that you may lose customers, the question is, how many fewer accounts will there be? Or how much will your revenue fall? Or maybe even increase. Yeah. So we will now try to find answer elements to these questions. So let's quickly define what elasticity of demand is. Elasticity basically measures the responsiveness of quantity demanded or quantity supplied to a change in one of the determinants. So this could be own price, the change in own price, change in substitutes or complement prices, or change in income, as well as many other factors that determine the quantity demanded and quantity supplied. Now we'll start with the price elasticity of demand. Price elasticity of demand measures the sensitivity of quantity demanded to changes in price of the good. So price elasticity of demand is calculated using this formula where we have in the numerator percentage change in quantity demanded. In the denominator we have percentage change in price. Now let's look at this case here where we have a rise in price from P1 to P2 by 10%. That rise in price induces a decline in quantity demanded. And that fall, the decline in quantity demanded is by 15%. So that's from Q1 to Q2. To calculate the price elasticity of demand for this good, then we take the percentage change in quantity demanded, that's in the numerator, and then we take the price change and put it in the denominator. Then the result will be 1.5. Now in terms of interpretation, if the price increases by 1%, the quantity demanded decreases by 1.5%. Yeah, so this is usually a negative value because it's a fall, while this is a rise in the prices. Yeah, so however, when calculating price elasticity of demand or when interpreting price elasticity of demand, we usually look at the absolute values. Yeah, absolute values. That's why we ignored the negative sign here. So now we will now apply these ideas and formula in our scenario. Remember, we had a business that maintains social media accounts for local businesses, and let's assume that this is the demand curve that we face, and currently at the $2,000 per business we have 12 businesses, or business accounts I should say, and at the price of 2,500 we expect to have only 8 social media accounts. So there's a reduction in our portfolio from 12 to 8 when we raise the price by $500, right? So to calculate the price elasticity of demand, we need to first calculate the percentage change in quantity demanded and also percentage change in price. So let's look at this rectangle here first. So using this formula now we will calculate the price elasticity of demand. So going from A to B is the first case. So we are raising the price from this point to this point. So we'll look at movement from A to B. So percentage change in P, or the price, given the details here, is 25%. Percentage change in quantity demanded is 33% decline, so that's a negative sign here, as you can see. But when we calculate the price elasticity of demand, then we ignore that negative sign. So 33 over 25 gives us 1.33, right? So that's the price elasticity of demand when we move from A to B. Now, what if we move from B to A? In other words, let's assume that we are currently managing 8 social media accounts, but we would like to reduce our price so that we get more customers. So we now need to calculate the movement from B to A. So there's a price decline here, yeah? So this is this rectangle here that we're going to look now next. So to calculate the percentage change, again we'll use the standard method of computing the percentage change. So percentage change in price is minus 20%. So that's using these two values in this formula. And percentage change in quantity demanded is 50%. And if we plug in the values into the standard elasticity calculation formula, which I introduced right here, so percentage change in QD over percentage change in P, yeah, we get 2.5. This is a little surprising, isn't it? When we move from A to B, we have 1.33, but when we move from B to A, the result is 2.5. So there is nothing changed here. Our values are the same as before. However, using this simple method of price elasticity of demand doesn't give us this consistent result. So it depends on which direction we are moving, whether we are increasing the price or decreasing the price. Now there is another method that will help us avoid this starting point problem, because if you remember, if you moved from A to B, we had a different result, and then if you moved from B to A, you had a different result. So with the midpoint method, we avoid that sort of problem. Midpoint method calculates the average value slightly differently. Now, the first formula here, the blue formula here, shows us the how we calculate the percentage change in midpoint method. So we take the end value and starting value as before. However, in the denominator of percentage change formula, we put midpoint, or the average value of the two values here. So here is this formula here. So to calculate the percentage change in demand, we take the end value Q2, take away the Q1, and in brackets divided by the average. You can see this average of the two, yeah? So average value of the two values. And the same is used in the denominator calculation as well. So price 2 minus price 1 divided by the average value of the two prices, yeah? Now this way we will not get different results for our elasticity calculation. So moving on now, we will calculate using the midpoint method price elasticity of demand for the business. So percentage change in price now, given these two prices, 2,500 minus 2,000 divided by 2,250. This value is the average value of these two. Yeah, so it's 2,500 plus 2,000 divided by 2 gives us this average value. Times it by 100% to get the percentage. Next, percentage change in quantity. That's equal to the difference between quantities over the average of the quantities. So 8 plus 12 is 20, divided by 2 gives us 2. So that's multiplied by 100. So that gives us 40%. Now we put these two results into the price elasticity formula. So that's percentage change in quantity in the numerator, the percentage change in price in the denominator. So the ratio is 1.8. So that's a different result than these two. These two have completely different results. Yeah, it is almost twice. So this value is almost double this value. Yeah, so that will give us a big range of values for elasticity. Now, in this calculation, we did this. We calculated. We moved from A to B. Yeah, so that's because end value was this value, beginning value was this value. Yeah. Now you can reverse this movement and then calculate elasticity for reduction in the price from 2,500 to 2,000, and then the sensitivity of the quantity demanded. So that can be done. We can do that using your calculators. Now we will not demonstrate that, but if you do so, you will get exactly the same result. That will be 1.8. If we increase the price by 1%, our quantity demanded will decline by 1.8%. Now we will look at the series of examples that will compare two common products to demonstrate the determinants of price elasticity of demand and how they affect the elasticity of the product. Now we will have these assumptions, and we try to answer all these questions. So first assumption is that the prices of both goods will rise by 20%. And we would like to know which good has the highest price elasticity of demand and why, and what lessons we could learn about the determinants of price elasticity of demand. Cheerios versus face masks. Cheerios are cereal products, and face masks obviously in general. Let's assume that price of both goods rise by 20%. For which good does quantity demand drop the most and why? So let's answer this question. Now, if you look at Cheerios, there are different types of cereals, yeah? So Cheerios has a lot of substitutes. If the price rises by 20%, and if that's a massive rise, depending on the price and starting point of the price, the customers may choose to substitute Cheerios with other breakfast products. But when the face mask prices increase, there aren't many substitutes in the market, so there is little effect on the demand, yeah, for face masks. So conclusion is price elasticity is higher when close substitutes are available. Yeah, so Cheerios would have many different substitutes, let's say breakfast products, but there aren't many substitutes for face mask. So next example, we look at Mountain Dew versus soda. So Mountain Dew is a carbonated drink, is a brand of carbonated drink, while soda is a range of carbonated drinks. It refers to all carbonated drinks, let's say, yeah? So let's assume that both products have prices increased by 20%. So for which good does the quantity demanded drop the most and why? So for a narrowly defined good like Mountain Dew, there are many substitutes, in other words, different other brands of soda drinks, yeah, or fizzy drinks. So a customer who drinks Mountain Dew, assuming that they are not addicted to Mountain Dew, switch to another carbonated drink. However, if all soda drinks increase in price, what happens is that there may not be substitutes available, yeah? There are fewer soda drink substitutes, in fact. So as a result, we can conclude that price elasticity is higher for narrowly defined goods than for broadly defined ones. And let's take another example with insulin and Rolex watches. Now again, we assume that the price of both goods rise by 20%, and again, for which good the quantity demand drops the most and why. Now, insulin is a necessity, and it's a life-saving drug. So as a result, even if there is a 20% price rise in insulin, the demand doesn't decline. People will still buy because it's a life-saving drug, yeah? However, when the Rolex watch prices increase, we would expect it's already these watches are already expensive, so, and also they are luxury products, so we would expect some people to not buy Rolex watches anymore. They are obviously more expensive, and they are luxury, and they are not a necessity, yeah? So price elasticity is higher for luxuries than for necessities. Now let's look at gasoline, and here we are looking at short run and long run elasticities. Now if the price of gasoline increases by 20%, well, we could expect that in the short run there is not much choice. People who are driving to work will have to drive to work until they have, let's say, other substitutes or other means of, let's say, commitment, yeah? The reason is in the short run we aren't able to sort of replace our cars, for example, or we aren't able to replace our vehicles, whatever vehicle is, so we will have to buy gasoline in the short run. However, in the long run, we may buy more efficient cars, or maybe electric cars, or maybe even just ride a bike to work, yeah? So depending on the time horizon, price elasticity changes, and price elasticity is usually higher in the long run. So in the long run, demand for cars will decline if the gasoline prices rise. price elasticity of demand takes various values. So let's start with the first one. Demand is generally referred to as elastic if the price elasticity of demand is greater than 1. And demand is inelastic if the price elasticity is less than 1. And demand is unitary elastic if the price is equal to 1. And if you remember, in our scenario, we calculated that our price elasticity of demand was 1.8. Let's go back. 1.8. So this is an elastic demand. Now demand is perfectly inelastic if price elasticity is equal to 0. In other words, demand curve will be perfectly vertical. So I'll demonstrate that with an example in the next few slides. Next, we have a perfectly elastic case when the price elasticity demand is a very large number, or an infinity, let's say. So demand curve is perfectly horizontal in that case. One important point here we'd like to note is that the flatter the demand curve, the greater the price elasticity of demand. So perfectly elastic demand is perfectly flat sort of curve, and so the flatter the demand curve, higher the price elasticity of demand. So let's look at an example here. So price elasticity of demand, as you can see, is calculated using this formula: percentage change in quantity demanded over percentage change in the price. Now, when the demand is perfectly inelastic, it will be a vertical line, and no matter by how much the price changes, only a single quantity is consumed or demanded. So quantity doesn't change at all. The quantity is always fixed no matter the price changes. Yeah. So the consumer is, in other words, not sensitive to prices. They would have to buy that minimum amount at least. Yeah. So elasticity as a result is equal to 0. So this denominator can be 100%, 200%, but the numerator will be always 0%. So as a result, price elasticity of demand will be 0. Now the inelastic case. In this case, the shape of the demand curve looks like this, a little, I should say, steeper. And remember, the flatter the curve, higher the elasticity. So this curve is a steep curve. In this case, notice this: if the price decreases by a large amount, the quantity demanded decreases by a small amount. So relative to the price, quantity demanded decreases, or sorry, in this case increases smaller. Yeah, so change in the quantity demanded is smaller relative to the change in prices. So opposite is true as well. You could simply flip this arrow and then increase the price from P2 to P1. The quantity demanded, as you can see, again increases only by a small amount. So the sensitivity of quantity demanded to price change is low in this case, and generally we will then get a smaller value than 1. So elasticity will be less than 1. That's because the denominator changes and numerator changes by a smaller amount relative to the denominator. So consumers' price sensitivity will be relatively low. Unit elastic demand happens when the percentage change in price is exactly the same as the percentage change in quantity. So 1% increase in price or decrease in price will lead to exactly 1% change in quantity demanded. So it's usually a case of intermediate sort of sensitivity. Yeah, it's just exactly the same quantity percentage change in both of these cases. When the curve gets a little more flatter, we have here elastically demanded good. Yeah, so this demand is elastic demand. And notice this now: when the price changes by a small amount, the quantity changes by a large amount. Yeah, so the sensitivity of quantity of demanded will be larger to small price changes. Consumers' price elasticity in this case is relatively high. And that's because quantity demanded in the denominator changes by a larger percentage point relative to the change in the price. So that gives us a larger than 1 value for the price elasticity of demand. So usually these such highly elastic products that command high elasticity would have more substitutes, and also they are usually luxury goods. Now perfectly elastic demand. It is a diametrically opposite case of perfectly inelastic demand curve. Now notice this, that the demand curve is horizontal. It's perfectly horizontal. A slight change in price will usually command a really high change in quantity demanded, and that's the consumer's price sensitivity will be very much very high or extreme, and elasticity as a result will be an infinity or a very large value here. Now, can we apply these cases in practice? Maybe yes, but there is not a single product probably that we can expect to have a perfectly elastic demand curve. However, we can have some sort of near perfect elasticity, for example. Yeah. So let me have a look. Let me show you that case here. So let's assume that you are a farmer and you grow wheat. Now you are in the market to sell the wheat, and you have a customer. Suppose that the market price for wheat is $5 per bushel, and also remember we defined the grain market as a near perfectly competitive market. Yeah, so that means the buyers and sellers take the prices as given, and slight change in the prices will usually mean demand for the product will sharply increase or decrease. So in this case, you are facing a customer who will be paying you a market price. You might want to ask, let's say, $5.01. Even that will drive the customer to another seller, because we defined the wheat market as the near perfectly competitive market. There will be too many substitutes, too many other sellers. Yeah, so your customer will easily find another seller who is willing to sell at $5 per bushel. So slightly changing your pricing, as you can see, reduces the quantity demanded. Similarly, if you reduce the price by one cent, let's say, and then you quote $4.99, you could expect a lot of customers coming to you to buy from your product, because usually when wheat is sold in large quantities and in perfectly competitive market, a slight change in price will usually draw a lot of customers to you. So it is a case of perfectly elastic demand, or example of a perfectly elastic demand. Yeah. Now here is a list of empirically computed elasticity values. These are taken from various studies. Now notice this. Depending on the availability of substitutes, the elasticity changes. So you look at eggs. Eggs have an elasticity value of 0.1, a very small elasticity. So eggs are inelastically demanded. In other words, there aren't many substitutes to eggs. But as you move down, you will see that the elasticity starts increasing, because there are substitutes of other products. For example, beef can be easily substituted with lamb or chicken, so the elasticity value for beef is 1.6. Peanut butter can be substituted. Restaurant meals can easily be substituted, yeah, or Cheerios will have a higher elasticity of demand as well. So as we move down, we will see that as products have more substitutes, their elasticity values also increase. Now, an interesting point here: elasticity is not constant along the demand curve. So we have here linear demand curve. By the way, along the linear demand curve, yeah, I should mention this. Now, elasticity along the demand curve changes. So if you move from this point downwards, let's say as we move down, elasticity declines. So elasticity between this point and this point is 5, and between this point and this point is 1, and between this point and this point is 0.2. So the product is elastically demanded between these two prices, but unitary elasticity is between 10 and 20, let's say, dollars, and then changes between 0 and $10 gives us an elasticity of 0.2. When the prices are higher, well, obviously high prices means not everyone can afford, and as a result, increasing the price further up, when the prices are already high, increasing the price further means a huge reduction in demand. Now take this case here between these 2 points. When the prices are already low, increasing the price, let's say by 10%, doesn't increase the cost to customers by much. So the customers will keep buying. So the quantity demanded is not affected massively here compared to in this sector here. But between these 2 points, price elasticity appears to be equal to 1. So it's the 10%, let's say 10% change in the price commands a 10% change in quantity demanded, while here 10% change in price leads to smaller change in quantity, while 10% change in the price here leads to a higher than 10% change in quantity demanded. Now we're back to the question that we asked earlier. What if we raised our price from 2000 to 2500? We now know that elasticity affects the quantity demanded here with our price changes, and we also established that our demand curve is highly elastic. And now we would like to know by how much revenue will change, or in other words, rise or fall. So we'll calculate the total revenue using this simple formula. We can expect the price increase to have 2 effects. First could be that the we would have a higher revenue because the price effect is higher. In other words, price increase by a higher amount relative to the quantity demand decline. Or we would expect lower revenue from an increase in our prices because for a small increase in our price, we might lose a large number of let's say customers. Now the question is, which of these 2 effects is bigger? Well, it depends on the price elasticity of demand. So let's look at these cases in graphs. So if we assume that our demand curve is slightly flatter, like in this case here, and when our price is $2,000 per business, then we will have 12 customers. So the total revenue is then 12 times 2,000. So that's this area. This is the total area. This large rectangle is our total revenue. That is 2,000 times 12, $24,000. So that will be our total revenue. Now that we would like to increase our prices to 2,500, so if that's done, we will now have only 8 customers with us. So that will be 8 times 2,500, a total revenue 20,000 pounds. So our total revenue now is 20,000 pounds. So it's this area here in this rectangle, yeah, area of this rectangle. Now notice what happens. This rectangle is smaller than this rectangle, and when we moved from 2,000 to $2,500, we lost this large revenue, while gained very small revenue increase. Yeah, so the difference between the 2 is the net gain or loss. Clearly we lost more than we gained, so there's a negative net gain, yeah, in revenue. So when we face elastic demand, or our demand is flatter, we shouldn't be increasing the price, yeah, because we will lose greater amount of revenue, and this is because our elasticity is greater than 1. Now let's assume that price elasticity of demand is less than 1, and we face a slightly steeper demand curve, and under the first scenario, when we have no change in our prices, that's $2,000 remaining as our standard price, then we will have our 12 customers. So 12 times 2,000 gives us the $24,000 revenue. So 24,000 is when we keep the prices as 2,000, and then only 12 customers, and we will serve 12 customers. Now let's assume that we raised our price to 2,500. That leaves us with 10 customers. So 10 times 2,500 now gives us the total revenue. That is $25,000 now, and our revenue is this is the area of this rectangle. Now notice this. Now when we increase the price from this point to this point, our revenue the revenue lost is this blue area. Yeah, this is the loss of the revenue from that change, but we gained a green area here. So this green area is larger than the blue area, and our net gain here is positive. Yeah, I mean the net change in our revenue is positive. So the conclusion is, when we have an inelastic demand, or our demand curve is steeper, raising the prices is recommended, or raising the prices gives us a higher revenue.